Okay, before we get into actually coding with Scratch, I just want to talk a little bit about pseudocoding. So pseudocoding is the idea of making a plan in real English terms about how you're going to go off and tell specific instructions to the computer about what you'd want it to do in your line of code. Pseudocoding is something that you'll see in our curriculum. Here's a more detailed definition about computational steps. English phrases used to explain a specific task within a program. Ideally, pseudocode should not include keywords in a specific computer language. The idea is this is more of a planning tool, so you don't need to actually write the computer code out. The idea is that your pseudocode is just a list of consecutive phrases that you would actually go off and do when you're making your plan. And it's good to plan this out ahead of time so that when you actually choose writing the code or choosing the block coding that you're going to do, you've got a clear direction of what you want to do. And then it's just a matter of figuring out what coding will make those things happen. So here's an example of pseudocode 1. So you see over here, these aren't actually what you would put into Scratch or any computer language that you're working with. You wouldn't actually go and say start the code. There'd be some block that you would pull out to start the code. But this pseudocode are the steps of instructions that you will eventually want to tell the computer to do. So here's an example of an input-output program. So you start the code, you ask the user to input 2 numbers. Those numbers are stored in some variables. And then you have this green command where in this case you're going to take the sum of half of the first number with double the second number. That sum then comes out and is stored in a variable called answers, and then you display that answer and end the code. This end the code part isn't necessary in Scratch, but in some other programs it is, so we may or may not use this pseudocode end the code. But if you're going to start the code, you might as well just plan to end the code. All right, so here's an idea. So what I want you to do, and you can pause the video if you want, is I want you to stop and think, if 5 and 4 were inputted into this code, what would the output be? So I'll give you a second to think of that. Maybe you paused, but now we'll talk about this. So we're inputting the 2 numbers are 5 and 4, and it says you're going to take the sum of half of the first number. So if the first number is 5, then half of that is 2.5. The second number is 4, and you're going to double that one, so that's times 2, so that's 8. So now you're going to take the sum of 2.5 and 8, which is 10.5 if you add those up. So this program, if the user put in the numbers 5 and 4, would spit out 10.5. And we can see that that is the correct answer. So I'll just erase that as we move on to the next slide. Oh, and I've got this part here covered up. All right, so now let's move on to the next slide. An interesting question is, so now that you maybe understand that, if 5 and 4 outputs 10.5, what would the output be if the numbers were entered in reverse order? So the first question I'd have for my class is, do you think the answer is going to be different? So you can stop and think about that, maybe give us a thumbs up or a thumbs down if you think the answer is going to be different, if the order matters. And then we can actually stop and think and say, well, it does say sum of the half of the first. So whichever one you put in first, you're going to perform the half operation. Whatever you're going to put in second, you're going to perform the double operation. So I think the order does matter. So if we flip this around and we inputted 4 and took half of that, that's 2. And if the second number is 5, you're doubling that, that's 10. And so now you're going to take the sum of 2 and 10 and see that C would be the output if you reverse the order. And we can check and see that, yep, indeed, that's correct. So again, the pseudocode is just asking you to think about what the steps you would have the computer do, and then this type of question is just practice for you reading the steps and understanding what a program might do. Here's another pseudocode. I'll give you a second if you want to pause to think about what the answer to this might be. If 5 was inputted into this pseudocode. Okay, maybe you've paused and are back. So let's try this. So now we're going to input just one number. That input is stored in a variable called number. And then this says step 1, you're going to square that number. So if 5 is our input, so there's 5 as our input, step 1 says you're going to square that number. So that means 5 squared. So remember, of course, 5 squared means 5 times 5 multiplied by itself is 25. So far we have 25. Now we see step 2, and we were squaring the number that we inputted. Step 2 now says 3 times step 1. Okay, so step 1 is now spits out an answer of 25. So we're going to use 25 in step 2. Not to the original number, because we're going to take our answer from whatever our computer did here in step 1, which was 25. And you're going to go 3 times 25, which is 75, and then minus 4 gets us an answer of 71. That is going to display in the answer for step 2. And so I'm going to say the answer here is going to be 71. And hopefully that's what you thought as well. Let's check, and indeed it is. Okay, so you see here the step 1 takes the input and puts it in a new variable called step 1, and then step 2 uses that new variable, that new idea of what spits out after step 1, and does a second operation. So this pseudocode would perform that. Nope, I got a 5 up there circled, so just erase that. Now, the reason I wanted to talk about this one is because you'll see when we get to EQAO, we're going to see this type of question on EQAO. And this is exactly the same as the pseudocode that I tasked you here. But it's kind of written a little bit different. So here's the pseudocode that they use. Number equals input, enter a number. So you're going to take a number, and it's going to go into this thing called number. And then step 1 is you take the number, and remember from when we did exponents on a computer, when you want to square something or raise something to exponent, use that little caret, that little hat, which is the shift 6. So this tells you you're squaring it. So you take the input number and square it. And then step 2 does something to step 1. 3 times step 1. So remember on the computer when you're doing times, it's the asterisk or the star symbol. Shift 8. So you take 3 times whatever step 1 is, and then minus 4, and then you display the answer from step 2. And so what would come out if we picked 5? Well, we've already done that math, and it would be 5 squared, which is 25. 3 times 5, 25 is 75, minus 4 is 71, and we would get 71 as our answer. Okay, so this is what we will need to get used to, because these are the types of questions you may see on EQAO around the idea of pseudocoding, and see if you can follow these steps. Here's another example. So a different line of pseudocode, still asking you to input a number. So you put a number. Oh, sorry. Before we get to that, excuse me, I wanted to make sure we talk about what the variables are. So we know we've seen the word variables. We've been using the word variable when we talk about algebra. Letters that represent unknown or changing things. So we've had variables like X or Y or rate of change or number of toppings. These are all variables that you would use to represent things that you don't know or that change in an equation. When we're talking in coding, excuse me, we're talking in coding, the variables are things that are inputted and stored so that the computer can use it. Again, they would change depending on the inputted number or what the user puts in or the commands that are done. So in this line of pseudocode that we just worked on in the last few slides, I wonder what the variables are. So it's kind of highlighted here, but the variables are things like number, step 1, and step 2. EQAO has made them bold so you can see that these are the things that are going to change. So the number value is going to change depending on what the user puts in. The example we did, we put in a 5, but maybe the user puts in a 7. And then all the other numbers or variables would change based on what that number is. So step 1 is a variable that's going to house an answer, and step 2 is a variable that's going to house an answer. And then we tell the program, hey, display the variable step 2, whatever that variable now is. Okay, so those are the variables. Here's a definition. Encoding a variable is a temporary storage location for data such as a numerical value or a series of characters like a word or letter. And these values are stored in that location. They vary depending on the commands given by the program. So step 1 and 2 will change as the number that's inputted changes. And so the variables will change. Okay, now I hinted at another example that we could look at here. So here's a different line of pseudocode. Maybe I'll zoom in here just so we can see it a little clearer. So this time you're still going to enter a number. Put that in the variable number. This time step 1 is 2 star the number, so you're going to multiply it by 2. Step 2 is you take it, and again there's that symbol, which means raised to the power of 3. So this time we're going to cube it, and then you're going to take that answer and do something to it in step 3, which is divided by 2. So this question then says, what would the answer be, or the output be, if if 3 is the thing we put in? So let's just back up here a little bit. So if 3 is the number we're going to put in, so we'll input the number 3. So this says we're going to input a 3. Step 1 says 2 times 3, so that's going to output 6. So step 1 is now going to, the variable is going to now be 6. Then we go to step 2, and it says take step 1, which we just said was 6. 6 to the power of 3, we would write that as 6 cubed. And I think if I go to my calculator, then let's see if I can pull up the calculator here. There it is. So we can go a scientific. We can go 6 to the power of 3. And we can confirm it's 216, or we could go 6 times 6 times 6. Just do it sort of manually. And we know that it's 216. So 6 cubed is 216, and that becomes the value of step 2. And then we use that in step 3, which is 216 divided by 2. And I think that's 108. And so now I would then say that based on this line of code, the output would be 108. And so I can see here that I've looked at this pseudocode, and I didn't just guess a number in multiple choice here. I had some writing that I had to do, some math I had to do before I could go off and write the answer of 108. And if I check on the next slide, I'll see that that is indeed correct. All right, so we're doing well here. I'm just going to erase this so that I can move on to the next slide. Just put this back here. All right, now here's an example of why it is sometimes nice to have the pseudocode for some more complicated situations. So for example, if you had a situation like this, you were trying to find the empty space in this cylinder that is not occupied by this cone, there would be a series of steps that you would have to do, and the order of that matters. And so you'd want to sort of plan this out in advance so that you can actually then go off and type these commands or use these blocks in your coding that you're doing. So some ideas of setting some things equal to 0, inputting what the radius and the height would be, performing the operations, and then to get some volumes, and then figuring out the empty space and spitting out the answer. Again, because this requires a bunch of steps, you'll want to make sure that you plan that out before you just start typing in code and maybe getting lost in the details. So here's an idea now that you can look at. I don't mind us just using this idea of the blocks to get us ready. So this time I want you to think about what the pseudocode is not needed to add two numbers and display the sum. So to help with that, here is the pseudocode I did for the first example, about half of the first number plus double the second. So what would the pseudocode for taking the sum of two numbers be? So I'll give you a second if you want to pause and try that on your own, and then come back. Okay, so we've probably thought about what we'd want. So of course we need to start the code here. We would want to input two numbers just like we did in the first case. Input, excuse me. We need to store those. So you might call them like the first variable and the second number or something like that. So store these variables so we can use them. And then this is the one that's going to be different. We're not taking half of the first and double the second anymore. We're just taking the sum of the two numbers. So you're just going to sum the first plus the second. That's probably the command that you're going to have to ask it to do. Add those two numbers up. Store your answer in a variable called answer. And then display the answer. And then, of course, you'd end the code, but in Scratch, you don't necessarily have to end that code. So let's see how we did. I'll just move on to the next slide that has the answer. Erase my little chicken scratch here, and see that it indeed does tell us we start, input the two numbers, store those numbers, add the first and the second, store the answer, display the answer, and end the code. Here's one that you won't be able to do, but I do with my class. Just ask people to rearrange these to put them in the order, and this time we're finding the square root of a number that is, and then round it. So again, we're just going to take these blocks and put them in an order. I'll give you a second to try that if you want to pause. Otherwise, we're just going to, obviously, we're going to start with starting the code. And then if we want, we need a number. So we need to get a number that we're going to input. So we're going to do that. We need to store that number someplace so we can perform operations to it. And the code, I'm sure, is going to go down here somewhere. So here we've got these two green commands where we actually do some math here. We're going to have to take the square root first before we round it. So that's important to think about. Store that answer, display the answer, and then end the code. So I feel pretty good about that. And you can see that, yes, indeed. So again, just by planning the pseudocode before you go off and start typing, it allows you to make sure that you, when you get into the typing or choosing the blocks in your coding, that you're just worrying about the actual specific things you're typing or the blocks you're going to choose because you already have the planning done. And here's one last one. Or one more, sorry, I don't know if it's the last one. So this is a neat idea that we'll do in future videos on looping. But if we look at this, it says start the code, and then you're going to do a loop. So in this loop, what you do is you ask the user to input a number, and you add that inputted number to something called the total sum. And then the loop means you turn around and loop back and do it again. So you do this until you get to doing it 5 times. So you're going to input and ask the user to input, add it to the sum, input, add it to the sum. Do this over and over 5 times. And what you're doing is getting 5 different inputs and adding those together. And then it looks like we divide this. After you do that loop, we now have that answer or that sum, and we're going to divide by 5, and then we're going to display it in a variable called average. Well, I think that's a big clue or hint about what this program does. It adds up 5 numbers. This is a cool way to code this, so you can input, instead of having to write out the line of code for input and add, input and add, input and add, and have all that down 5 times, you can do this loop and ask it to do it 5 times on its own. Add up those 5 numbers, divide it by 5, and we get the displaying of the answer. So this, of the average, excuse me. So this is going to do the average of 5 numbers that have been entered. All right. Oh, sorry, my screen already has the answers here. That's fine. So we had, this is what a similar type of question about organizing it might look like on EQAO. So they have these spaces and these lines of code, pseudocode, that you'll be expected to go and put in the right location. So I think it actually, maybe, I think this is how the question actually looked. So maybe you accidentally saw the answer, but that's okay. So here they are, and you're going to have to decide where these steps go. So I see this dividing by 5. If I think about my planning, you have to add everything up and then divide by 5. So this divide by 5 probably goes somewhere down here. I'm going to guess there, but we're going to stop. This idea of setting the result to 0, that's a great little thing that we would do at the beginning to make sure that there are no numbers already in there from previous runnings of the program where the variable might actually have a value. So a good little strategy when you're doing this is setting things to 0 at the beginning, so you're like starting with a fresh plate. Here's this idea of now calculating the result is adding the number that's inputted. That's part of this new this loop, adding the input to the total sum. So you see the result variable changes as you add another number. So you keep adding this number in this loop, and then this is, as we expected, would divide that result by 5, and now the result has a new value of the average, and we would have it like that. So again, here's another example of how you would see a pseudocode type question on EQAO. All right, so that sort of wraps up our introduction to pseudocode, a great strategy before you go off and do some programming. A little summary question here: which of the following describes pseudocode? A, a set of steps necessary to solve a problem. B, intended to be more generic in text than a specific coding language. And C, is a useful tool to plan the solution to a problem. And I think it's pretty obvious that pseudocode does all of those as a way of helping you in your first steps towards coding. Thanks very much and good luck.